Hello friends, welcome to SQL with Manoj. Today we'll talk about a new feature of SQL Server 2016, that is temporal data. Let me take you to the slides. So today in this video we'll talk about what is temporal data, what is temporal database, what is temporal tables, and the new feature in SQL Server 2016, what developers used to do previous to this, and what this new feature will give, what kind of flexibility this new feature will give to the developers without doing any major changes. So let's move to the next slide. What is temporal database? A temporal database is a database with built-in support for handling and archiving old versions of modified data over time. So temporal database is actually a concept not restricted to SQL Server, and it is as per the ANSI SQL 2011 standard, the latest one. So there are very few database providers in the market that provides this feature, and SQL Server has become one of those. So this feature, basically the temporal database, is an inbuilt support. Actually, as it's mentioned, inbuilt support means all the archiving and the modification of the data in a table is done by SQL Server only. You don't have to write your customized code. So this involves two tables. First, the temporal table, which will contain only the latest and fresh data, and second is a history table. This table is associated with with the first temporal table, and it is automatically created once you create a temporal table. We'll see that thing in our video. And this history table that is associated with this temporal table will contain all the old versions of the data that are modified over time, and every data will have a date range for the validity of that record. So this all thing SQL Server does internally, and it makes sure that these time ranges do not overlap with each other, making sure that these are unique records over time. And this concept is also related to the slowly changing dimension, that is SCD concept, and it is typically a type 6 SCD concept actually. So let's go to the next slide, which talks about why temporal. So as you can see here, and I already told you in the previous slide, there can be a lot of requirements for the business users to do analytics on the current year data, the previous year's data, or any point in time. So like a sales representative or a sales analyst, so the job of sales analyst is to analyze the sales happening, like he wants to compare the sales that happened today with the sales happened previous year or 2 years back or any point of time. So maintaining that temporal data is very important for that analytics. So till now the developer has to do a lot of work around to maintain this temporal data, so to make sure that all the historical data that is modified over time is stored seamlessly and correctly in the history tables. And he has to make sure that that data is not overwritten, that data is not corrupt, and he's not overlapping the date ranges in the history table. So the workarounds were very complex, expensive, limited, inflexible, and very inefficient. With SQL Server 2016, this thing has become very easier. There is no need to program anything, there is no need to change anything. You just have to create or modify those tables by adding the new feature that SQL Server 2016 has provided you, and that's a very small effort and does not involve any type of programming to archive the records. It's all internally done by SQL Server. So with temporal, what all you can do, so you can go to any point of time and do a time travel with the data. You can do the data audit, and you can implement slowly changing dimension. It will be very important for the DBAs also, because they will be able to go to the history of the data, and if there is any corruption happened or if there is any case of restoration of some particular record, that can, so DBAs can go to any point in time back and restore that record. Okay, so how this temporal data works? So as I told you in the previous slide, there is a temporary table and there is a history table associated with it. So the first thing is how the data is getting written. The second thing is how the data is getting retrieved. So in the first part, whenever the new data is written, it is written to the temporary table. Whenever a data is updated or deleted, it goes to the history table. So all the older versions of the data means if a data is modified, the older version of the data will go to the history table and the new version will remain in the temporal table. If a data is deleted, that will move to the history table and will be deleted from the temporal table. Okay, when you are going to retrieve the data from the temporal table, there is a particular clause that you will provide with the query, and with that particular clause you will provide the date range, like for which point of time you require the data. So as per the time mentioned in your query, it will go and hit the temporal table or the history table or both to give you the snapshot of that particular time. Okay, so there are some limitations also with the temporal tables, like temporal table querying over link server is not supported. History table cannot have constraints. Insert and update statements cannot reference the system time period column. Truncate table is not supported while system versioning is on. Direct modification of data in history table is not permitted. Instead of triggers are not permitted on either of the tables, and usage of replication technology is limited. Okay, so now we'll jump to the demo. Okay, so I have divided this demo into two parts. In the first part, we'll see how to create a new set of temporal tables, and in the second part of the same video, we'll see how to create temporal tables on top of any existing table. So let's proceed with the part one. Here in this part one, we'll create a department table, and we'll just take three columns: department ID, department name, and manager ID. And with this temporal table, there are few mandatory things that you have to keep track of and make sure that you are applying those. The first thing is that the temporal table here, in case the department table, should have a primary key. So here department ID, I have associated it with a primary key. The second thing is a temporal table should have two period columns that would tell me the validity of a record, or a range of a record, like what was the validity of this record from which date to which date. So here I've created these two columns, valid from and valid to. You can name them anything like start date or end date. The main thing is the data type should be datetime2 for both of these columns, and they should be assigned with generated always as row option, with for a start date with start keyword, and for end date for end keyword. So in my case, the valid from is start and valid to is the end. Also, both of these columns should be bind with the period for system time clause. So here in the within the brackets, I have bind these two columns, these two period columns. So this is the third condition, and the fourth condition is the system versioning option should be on, right? There is one more option, that is fifth, that is optional. The optional is the history table name. So this is the optional clause, and we'll see both of these options here. So I'll go to the first option where I'm not providing the history table name, and the SQL server will name it itself. So let's try to execute this. Okay, so I'm going to the object explorer and see the tables created over here. Okay, so we can see DBO department and system version. So in SQL server terms, a temporal table is also named as a system version table, and if I expand it, I can see the history table associated with this table um, internally. And the nomenclature of the history table it has done is like this: ms SQL server underscore temporal history for underscore, and this is the object ID of the parent table, that is department. So from ms SQL till for underscore will be common for all history tables. If you are not providing the history table name, so this name will be common. The only thing distinguishing a history table will be the object ID of the parent table, that is the this system version temporal table. Okay, so if I want to see the columns of the my parent table, that is DBO department, these are the columns. So first three columns are the columns for the department table for storing the department information, and the two columns valid from and valid to are the audit columns. And if I want to see the details of my history table, I'll just expand this, and these are the history, and these are the details of my history table. Same things copied over from the parent table to the history table. Now let's see how this has taken this ID here. So I have these two set of system catalog queries to check the metadata of both these tables. First query is for the temporal table, and the second query is for the history table. Let's execute both of them. Okay, so the for the temporal table, you can see here these columns. Okay, so this is the department table, means it is our system version temporal table, and the temporal type it is 2, and the object ID is this. And this also says that okay, it has a history table associated with it, that is 5090. It is here, object ID at the end 5090. Temporal type 1 means it is a history table, and history table ID null because itself a history table, so it will not have any history table. The name for this table is this ms equal underscore temporal history for underscore this ID. So if you can see this ID ending with 4976 is the same ID 4976. So by this way you can correlate the history table as well as the temporal table. Okay, so if you want to drop these tables, you cannot drop them directly. So if let's say I want to drop the temporal table, I'll get this error. And let's say if I want to, okay, so the name is changed, so let me also change the name here, because this was the temporal table, sorry, history table I created previously. Okay, so, and let me try to drop the history table also. I cannot drop it because the system versioning is on. So to drop them I have to switch the system versioning off, and then only I will be able to drop them. Okay, sorry, uh, single dbo, so only after that I'll be able to drop them. So let me refresh it. Okay, so you can see both of the tables are gone. So let's see the option 2, where we are creating a temporal table dbo.department and a named temporal history table with dbo.department history. So everything remains same, only this option you have to apply. You have to apply the history table equal to dbo.department history, and this is an optional clause. So if I execute it like this, and let me refresh the tables, okay, and expand it, you can see the department history table name instead of the earlier name that we got. So the earlier name we got was MSQL underscore temporal history for the object ID, but here by applying the history table name here, you get the history table with the following name, particular name, and all the things remain same, right? So let's check the metadata also here, right? So similar thing as we saw previously, the the temporal table department with the history table ID ending in 5261 here, and temporal type 1 history table, and the name is department history. Similar thing. Okay, again to drop these tables, you cannot drop them directly like this. So to drop both the tables, you have to set the system versioning off, then only you'll be able to drop them. So this was the part 1 where you saw how to create new temporal tables. Let's go to the part 2. We'll see how to create a temporal table on top of an existing table. So I'm taking an example of AdventureWorks database, and AdventureWorks 2014 database. As you can see here, I'm querying some tables to create a existing table because I did not find a use case for a temporal table in AdventureWorks. So I'm trying to join some tables and create a employee table, db.employee, with these columns: employee entity ID, first name, last name, and department name. So I'll just create a new table with the data populated here. And this is not a temporal table, this is a very simple table. You cannot see any history table associated with this, and it is just a select into clause. Okay, now we'll try to convert this employee table to a temporal table by few alter statements. So as in my previous part, in the part 1, I told you to create a temporal table there are few conditions. The first is it has to have a primary key. So I will alter this employee table and add a primary key. So here you go, I have the primary key here. And the second thing was to have two period columns, start date and end date here. So as you saw in the previous part, I had this valid from and valid to names. Here I am giving start date and end date. You can give anything here, right? But these two should be a part of the period for system time clause. So let's go ahead. This thing also done. And finally you have to enable the system versioning and provide the history table. So here I'm giving the history table name as db.employee history. Okay, let's go ahead with this. Okay, so if I refresh it, okay, so here you can see the employee table now has changed to system version table, and you can also see a history table underneath it, that is db.employee history, and with these following columns: business entity ID, first name, last name, department name, and the two audit columns, same columns being here in the employee history table, right? Business entity ID, first name, last name, department name, and these two started ended audit columns. Let's check the content of these two tables. Okay, so as you can see here, the first table, db.employee, has around 10 records, but the history table is empty. It does not have any rows because there is no modification done. It's just a new table. So let's go ahead and see how the employee history table gets populated while you do changes in the employee table. I will execute some update statements. As you can see here, I have three updated statements on business entity ID is equal to 5, the fifth record. So this is the one where business entity ID is equal to 5, first name is Gail and last name is Erickson and department name is engineering. So we'll try to do updates on these records and we'll see how the previous versions of these records flows into the department table. Okay, so let's go ahead one by one. So first of all, I'll update the name from Gail to Gabriel. Okay, here you go. Then I'll change the department name from engineering to research and development. And after that, I'll change from research and development to executive. Okay. So after the three changes have done in the employee table, let's go and see both the tables. As you can see here, you will see three updates happened and the older versions flown and stored in the history table. So the latest one was the name to Gabriel and the department name to executive. So here is the latest updation of these records, and you can see the start date is this 12/15/43 and end date is like it's like indefinite because this is the latest version. As you can see here, the start date is 1911. End date was the time when the first update happened, that the time when the name was changed from Gail to Gabriel. So this was the time. And the second update was to change the department name from engineering to research and development. So the second change went here. So actually I did these updates very frequently, so you will see the time ranges in seconds. And the last update, we changed the department to executive, so the executive is here and the research and development that was previously to it, so you can see it is recorded here as a third update, right? And if you see the pattern of this, the start date and end date, so these are non-overlapping and are in a continuation mode. Like the start date, this range starts from here and the end date ends from here. So the date is same 27 because this updation has happened today. And if you see the time 12/15/34, so the second update starts from 12/13/54 where it ended previously, and the validity of this record is 12/15/38 seconds. So it means this record was valid for 4 seconds. Similarly here you can see when this record ended, this version started. So the start date is 12/15/38 and it lasted till 12/15/43. So it lasted till 5 seconds, right? And after this 12/15/43, you will see the same timestamp here, 12/15/43, and even the microseconds you will see here. So this started from this particular time range and it is the current record. So that's why you are seeing this end date as 9999/12/31. Okay, now to show the demo of the time travel, like to go into past and point to a particular time and see what was the data at our hand. So what I'll do is I'll try to update the time periods to some point in history, like few days back, and then we'll see the demo. Okay, for this I cannot directly update the history table. To update the history table, I have to switch the system versioning off. So what I'll do is I'll alter the table employee and I'll update the system versioning to off and update the history table as per my needs. Okay, so now what I've done here is in these update statements, for these particular today's dates, I have backdated these dates to some previous dates. Like the first record backdated to 6/1, the second record was backdated to 6/1 to 6/10, and the third record was backdated to 6/10 to today's date. Let's enable the system versioning on after the updation of those records and see how these look like. So even if I updated today, I backdated them to some previous dates. So this looks like that this was updated on 6/1 and this record was updated on 6/10 and this particular record was updated on today. So that's why this is the latest version and these were the previous date ranges for these particular records. Okay, so now let's try to go back to the history and see what these particular records look like. So if I want to see the data, how it looked like on 1st of January. So SQL Server provides me an extra clause to put in my select query, that is for system time as of the time that you want to point to. So it will go back to that point of time and get the data from the history table for you. So this is the query that you can fire to get the data, what it looked like on 1st of January 2015. So let me just execute this data with this set of data itself. So you can see here on 1st of January the data looked like this. Gale Erickson Engineering, right? And it will also show you the validity of this record because it is pulling this data not from the employee table, it is pulling the data from the history table and it is pulling this particular record. Okay, now I'll comment this out. Let's check out this particular record. I'm trying to see the data that look like 3rd of June, right? So if you can see here, it is showing me, it is not showing me Gale, it is showing me Gabriel, Erickson and engineering, and it is showing me that this data was valid from 1st of July to 10th of July, means it has picked from this particular record. Okay, now I'll again comment this out and let's check the third statement, select statement. So okay, uh, I'll modify it to 20. So how the data look like on 20th of June, right? So it shows me Gabriel Erickson Research and Department, right? So and the validity of this data is 6th of June to 27th of June because I updated this research and department to executive today, right? If you can see the above query here, this was the last update on department name. It was changed to executive today, but on 20th, right? But on 20th it was research and development, right? And let's say how it looks today. You can just remove this thing and just execute it. It will show the data as of today with giving you the validity of this record. Okay, that after today and this particular point in time, the data looks like this: Gabriel Erickson and department name as executive. Now let's try to see the execution plan, how SQL Server does this all internally. So first of all, I'll just do a select star from my parent temporal table, and I'll see the execution plan, how does it shows up. Okay, so as you can see here, I'm just doing a select star from employee. It is getting the details from the employee table, right? But at the moment, if I apply this clause and try to pull data from past like this, so here in the execution plan, you can see it is also trying to contact the employee history table, right? And getting the data for me from the history table. As you can see here, so as you can see here in the properties, the actual number of rows is 1. So it means that it fetched the record from history table. But if you see here, the actual number of rows are 0 in the employee table. So it means that it didn't fetch the record from employee table, right? So this is the way SQL Server does internally. And if you can see here in the execution plan, it is referring to the current employee table as well as the history employee history table and doing a concatenation operator and giving me the final select list. And as I said earlier in my part 1 video, that if you have to drop these two tables, employee table, history table, or either of the two tables, you cannot do it directly. You have to switch off the system versioning to off, then only you'll be able to drop these two tables. Okay, so this is all about temporal table, and the demo of this temporal table in the part 1 you saw to create new set of temporal tables, and in the part 2 you saw how to create temporal tables on top of existing tables. Thank you very much for watching this video. In my next videos I will show you some maybe more examples on temporal tables or some new features of SQL Server. Please stay tuned. Thank you very much.